So today's notes are on kinematics, which we've actually already talked about because kinematics is simply the study of motion. But today we're going to focus on algebraic kinematics, and specifically on algebraic kinematics involving situations where there is acceleration. Because we've already looked at some of this with constant velocity in playlist 2. So today we're going to add acceleration to this discussion. But a lot of the beginning of these notes should sound familiar to you because we've already gone over a lot of the process for approaching how to solve this type of question. But we're going to be calculating for different variables relating to moving objects in this class. And we're going to be looking at things like average velocity, displacement, time, acceleration, initial velocity, initial position, and final position. And so you've seen these things up here before because, in fact, I think I had this exact same slide up here whenever we talked about the same topic in the constant velocity unit. We did a whole derivation of a problem for the two classmates or something that were like one catching up to the other one with that fun algebra. Today it's going to seem easier by comparison, I think. Okay, so again, steps for solving kinematics questions. So these are the same steps that I've already shown you once before, but we're going to review them. Your first step whenever you read any of these calculation type questions is going to be to define and label a positive direction. And you can define your positive direction in whichever way you want, but we do have a typical convention that we use, and you don't have to stick by it, but it might make it easier for you at times. And so by convention, we usually stick with kind of what you would think of as traditionally positive directions on like a coordinate grid in your math class, where you have like the things that are up toward the top of that grid of your like y-axis is positive, and that would be like north or upward, we think of as positive. And then things to the right of that grid are also positive, like the right of a number line, so we would call that right or east. And we think of those, generally speaking, as our positive direction. But again, you can define it for that situation. If it's easier to define it differently, you can. You do need to make sure that you label what your positive direction is. This is one of the things that they're going to be looking for on the AP test whenever they're scoring some of these calculation type questions. And this is going to be throughout the year, not just with this unit. You always need to label the positive direction. The second step for solving a kinematics question is to indicate in words what portion of the motion you are considering. If you're looking at a scenario where you have multiple objects, are you just looking at one of them? Are you looking at both of them? So what are you considering there? One object, two objects, however many. And then are you considering just the vertical portion of the motion, just the horizontal portion of the motion, the whole thing? If the question is telling you about something's motion over the course of 20 seconds, but then it asks you about, what happens at 5 seconds, then you would just be considering that portion of the motion. So it could also be based on, the time of the motion or something like that. But you need to indicate what portion of the motion you are considering. Step 3 is to fill out a chart of the 6 kinematic variables. And then it tells you to include directions and units so that you can see any discrepancies before doing the math. And so what I mean by that is that whenever you start to label these things, you've already defined your positive directions. So for example, if you have a scenario where you have like a ball bouncing off of a wall and it tells you an initial velocity and a final velocity, well, you need to make sure that you indicate the signs on those numbers, because if it's initially going one way and then it bounces and goes another way, then one of those numbers should be positive and one should be negative. And that should be indicated whenever you label those things for your variables. But again, that goes back to step 1, make sure you label the positive direction. Bless you. The second thing to do is to make sure you include the units, because if you read a question that says, a car is driving at 20 meters per second for 2 hours, and it starts asking you about, what happened in that time or how far it went or whatever, if that is the case, then if you label those variables in here, 20 meters per second and then 2 hours, you should notice right away that you have a discrepancy with your units. You can't do a calculation where your units aren't going to cancel like that. They either both need to be in seconds or they both need to be in hours. So again, if you label and include the direction in the units, hopefully you can catch any issues before you even do the math. But the variables that you're going to be labeling are the same ones on your AP Physics 1 formula chart. V naught, which is initial velocity, V, which is final velocity, A, which is acceleration, T is time, X naught is initial position, and X is final position. As a reminder, that little subscript 0 next to the V and next to the X means at time 0. So your velocity at time 0, or your initial velocity, or again, your position at time 0, or your initial position. Now, sometimes the question doesn't have the initial position, it doesn't start at time 0 or something like that. And so sometimes you will also, or instead, see it labeled as V sub I for initial velocity, a V with a little I next to it, and a V with a little F, V sub F for final. Same thing with the positions there. You could see X sub I and X sub F. So if you want to also make a note of that, you can. The reason that I don't have that up on my slides is because that is not how it is written on your AP Physics 1 formula chart. Okay, but you could see that. I actually prefer to write I and F instead of nothing and not. Okay, instead of V and V naught, I like VF and VI better, but that's not what's on here. Okay, but if you see that whenever you're looking up examples online, or if you see me do it in class, you should know that initial velocity can be written either way, V naught or VI, and final velocity can be written either way, V or VF. Same thing with anything that has initial and final. You'll see the subscripts. Okay, so again, step 3, fill out your label all your variables. Step 4, choose the kinematic equation or equations that you need to use to find the final answer, and that's going to be based on the variables you labeled. And so if you're reading the things that you labeled, you will then look at this list of equations, and by the way, these 3 equations, the first 3 are the first 3 on this sheet. The AP Physics 1 formula chart, first 3 equations are in order on my screen right now. 1, 2, and 3 underneath the mechanics section. You're going to see these equations. This 4th one is not on your formula chart. It is one that you can use, though, if you have it memorized. But again, you'll be able to refer to these, and depending on the variables that you have labeled, you can pick the appropriate equation for that scenario and then work on solving it. Okay, so let's go ahead and take a look at an example. The example says, a bus is moving at 20 meters per second and begins to slow down at a constant rate of 3 meters per second. How long until it stops? So we're going to go through the same steps that we just talked about. And step 1 is to label the positive direction. So whenever I take a look at this question, to make my life easier, I am going to label my positive direction as the direction that the bus is moving. I'm going to say the bus is moving in the positive direction. Whatever direction that may be, that's wherever the bus is going. Okay? So that's step 1. We've labeled our positive direction. Step 2 is what portion of the motion am I considering? Well, I'm obviously just looking at the bus. That's the only object there. But I'm also specifically looking at the bus for the entire time that it's slowing down from 20 meters per second to 0, because it says until it stops. Okay, so I'm looking at that entire slowdown. Okay, the 3rd step, again, is to label all of the variables. And you'll notice that I already have some of them listed down here. Actually, all of them listed down here. So let's start with our initial velocity. The question tells us that the bus is moving 20 meters per second. I am specifically going to call that positive 20 meters per second because I identified that as my positive direction. What is my final velocity going to be? 0, because it says until it stops. It doesn't have a number, but if you see the word stops, you need to know, okay, that's 0. So my final velocity will be 0. Okay, what about my acceleration? What am I going to fill in for that? -3. Yeah, good job, guys. -3. Don't put a 3. I know the question says 3, but you had to define the direction, and you said that the bus was going in the positive direction. If something is slowing down, that means its acceleration has the opposite sign of its velocity. So if its velocity is positive and it's slowing down, its acceleration has to be negative. Now remember, slowing down doesn't always mean negative. If I defined my direction differently, if I said the bus was moving negative 20, my acceleration would in fact be positive 3, and that would still mean slowing down. I just need an opposite sign. Okay, so make sure that you understand that as well. All right, so I've got the first 3 labeled, and that's the only 3 pieces of information we have because they didn't give us a time. In fact, they want us to find it. And then they didn't tell us anything about the position. Now, I will say this. If we needed it, I could go ahead and just say, well, why don't I just call my initial position 0? It didn't define it otherwise. The only question they could possibly ask me is, how far has this thing traveled after it stops, like until it stops? In which case, I would be able to solve for x if I knew my initial position was 0. It's easier to do that. Okay, so you could put a 0 in there if you would like, but we actually don't need that number to answer this question. Okay, so we've got all of our variables. The next step is going to be to choose the correct equation from the sheet. Okay, and I've outlined my unknown there. I'm looking for time. So with that in mind, I have this information, V naught, V and A, and I'm looking for T. Take a look at the equations that you either copied down in your notes, or if you didn't write them down, take a look at your AP Physics 1 formula chart. Which equation should I use based on the information that I have labeled on my screen? Yeah, they were numbered on my screen earlier, right, in the notes. And yeah, number 1, that's absolutely correct. This equation, okay, V equals V naught plus A times T. Now, could I do it differently? Yes, I could. Okay, if I wanted to, I could use the third equation because I know V and V naught and I know A, but the third equation doesn't allow me to solve for time. I would then be solving for position, and then I could go to a second step and use the position to find time. But why would I do that if I have an equation that lets me do everything in one step? Okay, so there is always, I won't say always, but almost always more than one way to solve these things, but there's usually an easier way and a harder way. So it's up to you. But this equation is the easier way. Okay, so I have V equals V naught plus A times T. We're trying to solve for time, so I'm going to rearrange the equation with the variables to isolate T and then plug the numbers in because, again, you should be practicing this for those derivation type questions. So if I wanted to isolate my time, I need to get it by itself, and so the first step is going to be subtracting V naught from both sides because it is currently being added. Okay, so I'm going to subtract V naught. That leaves me with V minus V naught equals A times T. And again, I'm trying to get time by itself, so my next step is dividing both sides by A, and that leaves me with this. Time equals V minus V naught divided by A. That is the equation that I'm going to substitute my numbers into. When I substitute in, it looks like this: 0 minus 20 over negative 3, which is just negative 20 over negative 3, which equals 6.66666. It goes on forever, but I'm going to round that to 6.67 seconds. Are there any questions about this example? Okay. So again, be able to do things like this. I told you this would seem easier in comparison to the one with the 2 people that were walking. And they're, usually a little bit more straightforward like this instead of the other one, but you should be able to do it both ways. So this is what you're going to be expected to do for kinematics, is use these types of equations and go through those series of steps to answer problems like this one here. Okay, you guys have some work to do today. If you have any questions about that, what you're doing in there, please let me know.